Okay, so if you've ever been in a cybersecurity lab, you definitely know this feeling. You've done your homework, you've found a target, you've picked the perfect exploit, you hit run, and nothing. The exploit finishes, but that shell you were waiting for, it just never connects. It is, without a doubt, one of the most common and frustrating things to run into. So today, we're going to do something a little different. We're going to treat this problem like a crime scene, and we're going to run a full investigation to find out who the culprits are.
Right? You see that message? Exploit completed, but no session was created. And your heart just sinks a little bit. What went wrong? Was it my network setup? Did I pick the wrong exploit? Was my payload bad? Well, today, we're putting on our detective hats. We're going to investigate the most common reasons this happens so you can solve this case every single time.
Our first suspect, and honestly the one that's guilty about 90% of the time, is the connection itself. You know, in a virtual lab, how your machines talk to each other is everything. If the target machine can't talk back to your attacker machine, the exploit is just going to fail silently. So let's take a closer look at the evidence.
And here it is, the root of so many problems. See, if your virtual machines are set to NAT mode, your attacker machine is basically hiding behind a one-way mirror. The target has no idea how to get back to you. This is why setting Metasploit's L-host, your local host IP, is so critical. It has to be an address that the target can actually see and talk to. But in bridged mode, well, now both of your machines are on the same local network. Just like two computers in the same room. They can talk to each other directly, no problem.
This right here is exactly why that direct connection is so important. Almost all Metasploit payloads use something called a reverse shell. Now think about it. Instead of you, the attacker, trying to knock on the target's front door, which is probably locked by a firewall, the exploit makes the target machine pick up the phone and call you. So here's the crucial part. If your attacker machine is unreachable because it's hiding behind that NAT network, that phone call is never going to get through. Your machine is just sitting there waiting for a call that can't connect.
All right, so let's say your networking is totally fine. You're in bridge mode, the machines can ping each other, everything's great. But you're still not getting that session. Well, it's time to question our intelligence. Our second line of investigation is all about the quality of the information you gathered before you even thought about launching the attack.
An Nmap scan like this is our primary piece of evidence. It's our smoking gun. Now, we see port 21 is open, it's running FTP, that's interesting, but that's not the golden nugget. The real clue, the key to this whole case, is right here, VSFPD 2.3.4. That specific version number, that's what we need.
And I really can't stress this enough. Version is absolutely everything. Exploits are not a one-size-fits-all kind of deal. They are incredibly precise tools, kind of like a surgeon's scalpel, designed to work against one specific vulnerability in one specific version of a piece of software. So if your Nmap scan says version 2.3.4, trying to use an exploit for version 2.3.5 is almost guaranteed to fail, even if Metasploit says the exploit completed. Your intel has to be exact. So, we've confirmed our network is solid. We've confirmed our intel is precise. We have the right key for the right lock. But the job's not done yet. Our third and final investigation focuses on the tool you use after you've picked the lock, the Metasploit payload itself. Let's be super clear about what a payload is, because it's easy to get confused. The exploit, that's the key that gets you through the door. It unlocks the vulnerability. But the payload, that's what you send through the open door to actually get something done. It's the little piece of code that connects back to you and gives you that command shell, or even better, that powerful meter preader session you're really after. Now, choosing the right payload isn't just guesswork. It's a really simple three-step process. First, you got to match the operating system. You can't send a Windows payload to a Linux machine and expect it to work. Second, you have to match the architecture. Trying to run 64-bit code on an old 32-bit system? Yeah, that's a recipe for failure. And finally, you just have to decide what you want to do. Do you need a basic command shell, or do you want the all-powerful, feature-packed meter preader? Just answer those three simple questions, and you'll make sure you're sending the right tool for the job. So, after a pretty thorough investigation, we've identified our main culprits. We've gathered all the evidence, we've interrogated the suspects, and now it's time for the verdict. Let's put everything we've learned together into a simple, actionable checklist you can use every single time an exploit doesn't connect.
And here it is, your 5-point inspection. Run through this every time. First, network. Are you in bridge mode? Can your machines actually ping each other? Second, L-host. Did you double-check that your local host IP in Metasploit is your attacker's IP on that bridge network, the one the target can actually call back to? Third, intel. Does your exploit
perfectly match the service version from your Nmap scan. Not close, but exact. Fourth, payload. Is it the right one for the target's OS and architecture? And finally, number 5, the wildcard. Could there be a firewall on the target machine that's just silently dropping your connection? You run through this list and I guarantee you will find your culprit.
And just like that, we've closed the case on this silent, failed session. What used to be a really frustrating mystery is now just a logical troubleshooting process. With this framework, you're not just throwing exploits at a wall and hoping they stick. You're systematically diagnosing and solving problems like a real detective. So the only question left is, what's the next mystery you're going to solve?